Okay, so welcome everyone to this class. So in today's class, we are simply going to solve some of the questions in this tutorial sheet 3. So tutorial sheet 3 is on further integration. Okay, so they are quite interesting questions that we're going to encounter here. And we're going to use different methods, okay, of integrating. There's substitution, there's integration by parts, okay? So a lot of methods that we're going to use to tackle these questions that are in tutorial sheet 3, okay? So for those who have never attended a class at Discrete Learning Institute, we also have videos for the other tutorial sheets, okay? Like for all the questions, we already have the videos, so you can access them on our website or on our mobile app. So tutorial sheet 1, 2, and 4. We already have the full videos. Okay, we're just remaining with tutorial sheet 3, which will also finish by tomorrow. I think I'll record all the videos for all the questions. Okay, so there are different questions here. So question 1, we already solved it. The video is there on the website. So today I'm going to focus on I'm going to focus on question 2, which deals with integration by parts. Okay, but these all these other questions again, they have videos. I'm almost solving the last question, then I'll upload them on the website so you can access them there. Okay, so now in this video, we'll focus on integration by parts. So we're going to solve these questions here. Okay, so integration by parts, it's a very nice technique. Okay, it's a very nice technique that we use to integrate, but you have to know some few things. Okay, so if I have the integral, okay, of u, and then I have dv, okay? When I'm doing by parts, this is the same as uv, okay, minus the integral of v du. Okay, so v du. So you see that here we started with the u dv, right? And then we're saying uv, and then on the other part, we're saying the integral of v du. So in some other books, you'll find that they write this formula in the following way. They'll say uv is equals to the integral of u with respect to v, and then plus the integral of v with respect to u. So other people, they write the formula like this, but the most common one that we're going to be using in this session, we're going to be using this formula here. Okay, so all these questions here, we're going to apply this formula. Okay, on some of them, we're going to apply this formula here. Okay, so let's start. So we're going to be using this same formula here. So I'll just write it uh, here. So I'll say the integral of u dv is the same as uv minus the integral of v du. So please, guys, as we'll be solving these questions, feel free to ask questions. Okay, if you have any questions, feel free to ask. Okay, so we start with question A. So question A, they're saying find the integral of 3x e to the power minus x and then dx. Okay, so we're going to um, we're going to integrate this using this formula. Okay, so the issue here when you're integrating by parts is how do you choose your u and how do you choose your what? Your dv. Okay, so you choose the u, okay, for the term that is very easy to differentiate. And then you choose the dv for the term that is very easy to integrate. Okay, so I'm sure you learned all the differentiation technique when in first semester. Okay, so we're going to apply some of those. So here I can write this, okay, in the following way. I can say this is the same as, or let me choose my u and my v. So I have these two terms. You have 3x, and then I have e to the power minus 3. Okay, so which one there will I choose as my u? So the one that you choose as your u should be something that is very easy to differentiate. So this 3x here is very easy to differentiate. So we're going to say my u is 3x. Okay, and then whatever will remain after you pick your u will be your what? Your dv. So my dv will be, what has remained is e to the power minus x and then dx. Okay, so from these ones now, we're going to find the du, because on the other side there, you can see we can have the du. Okay, and then from this dv, we're going to find the what? The v. So how do we find the du from this? We just have to differentiate with respect to what? To x. So here I'll say my du is equals to, then I differentiate this with respect to x. I'm just going to get 3, okay, and then dx. Okay, so that's my du. And then how do I find my v? Okay, since this one is dv, when I integrate it, okay, when I say the integral of dv, this is the same as v. Okay, because this integral and this differentiation sign, which is dv here, they will cancel out. So I just remain with the v. So v is the same as the integral of dv, okay? But the integral of dv is what? Is this guy here. So it is e to the power minus x dx. Okay, so how do you integrate e to the power something? Okay, you get the derivative of the power. So what is the derivative of the power? Okay, if I differentiate this minus x, I'll just get minus 1, right? So the integral of e to the power minus x is e. You write it the way it is, just the way it is, and then you divide by the derivative of the power. So the derivative of the power is minus 1. Okay, so this simply means my v is minus e to the power minus what? X. Okay, so once you get these now, you can apply them using this formula. So I'm going to say this is equals to, what is my u? My u is 3x. And what is my v? My v is minus e to the power minus x. Okay, and then I say minus the integral of, what is my v? Minus e to the power minus x. Okay, and then what is my du? My du is this one here, the 3x dx, the 3 dx I mean, so I'll put 3 dx. Okay, so from there, we see that we can multiply this guy, so it will be minus 3x e to the power minus x, okay? And then from there, on the other part there on the right-hand side here, okay, I say I have a negative inside here, so I can pull out this negative to come outside here to combine with this negative, so it becomes a plus, and then I remain with what? I remain with okay, I remain with what now there? So here, okay, I remain with 3e to the power minus x and then dx, right? Okay, so that's what I remain with. And then from there, okay, what are we going to do? I can say, okay, this one, the first one, I keep it the way it is. Okay, but I still have to integrate this. So here I can pull out the constant to go outside there. Okay, so it will be plus 3, the integral of e to the power minus x dx. So what is the integral of this guy here? We already found it here, which is what? Minus e to the power x. Okay, so this part here becomes e to the power minus x, this part here. Okay, so it means our final answer, okay, I can erase what now? I can erase this part. Okay, so it means my final answer will be equals to minus 3x e to the power minus x, okay, plus 3, and then the integral of this guy, we said it was what? Minus e to the power minus x. So it means what I have is minus 3x e to the power minus x, and then minus 3 e to the power minus x. Okay, so that would be our answer there. And then we also add the constant of integration. So just say plus c. Okay, so any questions there on how we have found that answer? Any questions there, guys? Be free to ask. You can even factorize here what is common. So what is common there is the minus 3e to the power minus x. So it means here I'll just remain with the x and then plus. Here I'll just remain with the what? A 1 and then plus c. So you can express it as this or express it as that. So any questions there on what we've done? Any questions there, guys? Okay, so if there are no questions, let's move on to part B. Okay, so we're still using the same integration by parts formula. So this one now it will be b, the integral of ln x over x squared. Okay, and then dx. So I can write this as the integral of ln x multiplied by 1 over x squared and then dx. Okay, and then from there I'm going to choose my u and my what? My dv. So the u here, we're going to choose the ln x because it's very easy to differentiate. Okay, and then the dv, we're going to choose the 1 over x to the power 2 and then dx. Okay, so let's find the du from this. So how do you differentiate a ln? Okay, how do you differentiate a ln? So in tutorial sheet, what was that? Tutorial sheet 2? Is it tutorial sheet 1 or 2? 2. Okay, in tutorial sheet 2, we are looking at different ways in which you can differentiate these functions. So this is a logarithmic function. So we said to differentiate such, you differentiate whatever function is there. So what is the derivative of this x? It's 1. and then you divide by this same function here, which is just x. Okay, so that is the derivative of ln x. It's 1 over x, and then you say dx. And then here we want to find the v. So the v is just the integral of this part. Okay, so we are integrating 1 over x to the power 2. But 1 over x to the power 2 is the same as x to the power minus 2, and then dx. So what are we going to get here? So we know when we're integrating, we add the power here, and then we divide by that new power, right? So it will be x to the power minus 2. I add plus 1, and then I divide by this same power, which is what? Minus 2 plus 1. So this gives me a v of um, x to the power minus 1 over minus 1. So this simply means I have, okay, I have minus 1 over x like this. So this is the integral of this guy or this guy. It's just this integral here. Okay, so it means now I have my v, which is this. I have my dv, which is that. I have my u, and I have my du. So I can add or put them in this formula and then evaluate the integral. Okay, so that's what we're going to do. So I'm going to say this is equals to the u, okay, is ln x. And then the v I found is minus 1 over x. And then minus the integral of the v, which is minus 1 over x. And then the du is this whole thing here, which is 1 over x, okay? And then dx. Okay, so from there, we can evaluate this guy. So I erase this part. Okay, so it means we're going to have this is equals to, okay, so here I'll have minus 1 over x and then ln x. Okay, there's nothing that I can do about that. And then on the other part, I have a negative here on top with this one. And I can also see a negative here. So I can put this negative to have a positive sign there. Okay, so what do I have? I have plus the root of, oh, I mean, I have plus and then the integral of, this is 1 multiplied by 1. So I get 1. X multiplied by x, I get what? X to the power 2, and then dx. Okay, so what is the integral of this? Okay, we already found it. The integral of this, we had found that it is minus 1 over what? X. So here, where we have this integral, I'm going to put the minus 1 over x. So this will be equals to minus 1 over x, ln x. Okay, and then the integral of this, we already found that it was minus 1 over x. Okay, and then I add a constant of integration. So here you see that the minus 1 over x is common. So I can factorize it. So I remain with what? Ln x, and then plus 1, and then plus c. So this one here will be our integral for the second equation there. Okay, so any questions there? Okay, if you have any questions, please ask. Okay, are you saying no, or you want to ask a question? Okay, I didn't get you.
I was just saying no.
Oh, all right. All right, then let's move on to C. So C, it's a very interesting question, okay? Because it will require us to think more than we have done on B and A, okay? So take a closer look at what is going to happen on C, okay? Sometimes the questions will be like that. So we have the integral of e to the power x, and then cos x, and then dx. Okay, as usual, we have to choose our u, and we have to choose our what? Our v, our dv. Okay, so in this case here, our u, we're going to choose something that we can easily, in fact, here you can choose any of them. Okay, so you can choose your u to be e power x, it's going to work out still. You can choose your u to be cos x, still going to work out. Okay, but for myself, I'm going to choose u to be cos x. Okay, and then I'll choose my dv to be e to the power x dx. So from this here, I can find the derivative of a cos x. So what is the derivative of a cos x? We know it's a minus sine x. Okay, and then dx. Okay, and then here I want to find my v. So my v, I just have to integrate both sides here. So if I integrate this, I get my v. If I integrate this side, okay, what am I going to get? So what is the integral of e to the power x? Like this. Okay, so the integral of e power x, remember, we write the function first the way it is, e power x, and then we divide by the derivative of the power. So the derivative of this power is still 1. Okay, so we're just going to say e power x again. So the v here is e power x. Okay, so that simply tells you that the integral, okay, or the derivative of e power x, it's always the same thing. Okay, you can differentiate it 100 times, so it's going to give you the same thing. It will just be e power x, e power x, e power x until wherever you are going. And then from here now, we can apply that formula. So I'm going to say this is equals to this guy, my u, which is cos x, my v, which is e power x, okay, minus the integral of, okay, the integral of, what is my v? My v is e power x, okay? And then my du, it's minus sine x dx, okay? So we notice here that I can actually, what can I do there? I can actually take out the, um, okay, I can actually take out the, this negative here. I can take it out. So it will be, this whole thing is equals to, okay, I can even write this as e to the power x cos x plus the integral of e to the power x and then sine x dx. Okay, so we still have to evaluate this integral here. Okay, so how are we going to evaluate this integral? We are also going to apply the by parts formula again. Okay, we'll apply the by parts formula on just this part here. Okay, so what you notice is that if you apply the by parts formula here, it's going to take you back to this. Okay, it's going to give you this same thing that you are seeing here. Okay, so if you do by parts again, it's going to take you to this. Do by parts, it's going to take you by it. So it will just be moving you from one form to the other, and it won't give you an answer. So what we're going to do here is use a very good technique. Okay, we're just going to evaluate this one once. Okay, so let's apply by parts here. What are we going to get? So let's choose our u, our v, and our what? Our u and our dvm. So I'm going to choose my I'm going to choose my I'm going to choose uh, my u as this sin x, okay, and then my dv, okay, as e to the power x dx. So please, guys, if you have a question, ask. So du here, what's the derivative of a sine? It's just a positive cos x. And then I write dx, and then here I'm finding my u, so I integrate this side, I get u. When I integrate e power x, what do I get? I get the same e power x. Okay, so here on this part, okay, it's going to become what? So this part here, just this part here in this box, let me put it in a red box like this. So this part in the red box, without considering this, will become u. What is my u? It is sine x. Okay, my v, it is e power x. And then I say minus the integral of my v, which is e power x. And then what is my du? My du is cos x dx. Okay, so this part here, we're going to replace it with this. Okay, so now look what I'm going to write. Okay, so this is our integral, which is equals to all of this, right? So we're going to write it in this form. So I'm going to say my integral, okay, e power x cos x dx is equals to this part, e to the power x cos x, okay? And then plus this part here has just become this whole thing, right? So I'll write plus sine. Okay, maybe I should write it in this form. I should say e power x sine x, okay? And then there I should say minus the integral of e to the power x cos x dx. Okay, so now what can we see? On the right-hand side, I have this part. On the left-hand side, I mean, this is the left, right? So on the left, I have integral of e power x cos x dx. Even here, I have the integral of e to the power x and then cos x dx. So these two are similar. So what are we going to do? We're going to take them to the same side. Okay, so I'm going to take this negative one, this one, I'm going to take it to the other side so it becomes a positive. So it will be this one plus this one. So I have two of them. So it will be 2, the integral of e to the power x cos x dx is equals to, here I have e to the power x, okay? And then cos x plus e to the power x, and then sin x. Okay, so here now, you see that to find the integral of this, we just have to divide by 2. This side and this side by 2. So it will mean that my integral of e to the power x cos x dx will be equals to, okay, this same thing that I've written. So I can also write it as half and then multiplied by e to the power x cos x plus e to the power x sine x. Okay, so that would be the answer for part C, this one here. And again, don't forget the constant, so you can just say plus C for the constant there. Okay, so any questions there on how we have found that answer? Any questions?
Excuse me, sir.
Yes.
Okay, so for the U part, when you're integrating, let's just say we had chosen cos x dx to be our v and not our u. Would you still get the same answer?
No, you won't get the same answer because
Oh.
look at the formula here. So the formula here at the beginning, you've seen this part here. It has u and dv. So from the given equation that you have been given, okay, you have to choose your u and your dv. You don't choose your v and your du. No.
Oh, okay. Thank you.
Yes. All right. Okay. Then let's look at part D. Okay. I hope part D has something interesting. Otherwise, I love this one here because it's very interesting. This one here. But anyway, we'll reach that part. Let's look at part D. Okay. So on part D, we have the integral of x squared sine x and then dx. Okay, so let's choose our u and our dv. Okay, so our u, this is very easy to differentiate. So we can just choose it, the same one. So u will be x squared, and then my dv will be equals to sine x dx. Okay, and then here we find our du. So we differentiate this. We're going to get 2x dx. Okay, and then from here, we're going to get our v. So we are going to say this will be v is equals to. So when I integrate this side, it gives me v. What if I integrate this side? So it is the integral of sine x dx. So what is the integral of sine x? Okay, it's a minus c cos x. That's the integral of the sine. Okay, all right. And then from there, we can just place them in the formula. Okay, so this is the formula. So I say the integral of x squared sine x dx is equals to, so my u is x squared. My v is minus cos x, okay? And then what is my minus the integral of my v, which is still minus cos x. And then my du, it's 2x dx. Okay, so from here, we see that we can what can we do there? Okay, from here we see that this one we can combine it. So it will just be minus x squared cos x. Okay. And then here we're going to say let's push this negative outside there. So it becomes a plus. And then I have the integral of, so I can put 2x and then cos x and then dx. Okay. So what do you think we should do there? Okay, in order to evaluate this integral here, what do you think we should do? Anyone who has an idea on what we should do there? Okay, so there we apply the by parts formula again on this guy here. Okay, we apply the by parts formula again on this part, on this guy here, because it has two functions. There's this function and this function. So we apply the by parts again on this. So what are we going to get? Okay, so we have to choose our new u and our new dv. Yes, dv. So our u will just be the 2x. Okay, and then our dv from this guy here will just be my cos x dx. So it means what we have here will be the derivative of this. So du will be equals to 2 dx. And then v will be equals to the integral of cos x. So the integral of cos x, it's a positive sine x. Okay, so this one, if I can write it here, to be the integral of 2x cos x dx will be equals to. So my v, my u is 2x, and then my v sine x minus the integral of my v, which is sine x. Okay, and then what is my What is my du? My du, it's 2 dx. Okay, so from there, what do I get? I get 2x sine x minus, this 2 can come outside, so it will be 2, and then the integral of sine x dx. Okay, so this will just be 2x sine x minus 2. Then what is the integral of sine x? Okay, so the integral of sine x, we said it's a minus cos. So this will just be a minus cos inside there, like this. So it means I have 2x sine x plus 2 cos x. Okay, so this part here, the 2x cos x dx, this one here, we're going to replace it by this. So it means our answer will be what? Okay, so let's write it here. So it means my answer to the integral of sine x, x squared sine x dx will be equals to, the first part is minus x squared cos x, okay, plus, and then the integral of this, we have found that it is this. So it will be 2x sine x, and then plus 2 cos x. Okay, and then we just add a constant of integration there. Okay, just add the constant of integration. So if you want, okay, you can factor out this cos and cos because they are common. So if I combine this part and that part, it will be what? Okay, so it will be 2. The 2 is from here, and then minus x squared, and then I factorize this cos x, okay, plus 2x sine x, and then plus c. Okay, so that is what we have there. So that will be our answer there. So any questions there? Okay, before we look at E. So E is very interesting, okay, because it will require us to use some substitution in the by parts formula. Okay, so if there are no questions, let's move on to E then. Okay, so I'm going to erase this. So on E, okay, we need to think a little more. So on E, we have the integral of x to the power 3, and then root of 4 minus x squared, and then dx. Okay, so here, what we're going to do is that before we choose our u and our dv, we're going to manipulate this equation, okay? We're going to manipulate this equation in another way, okay? Because if you just use it direct the way it is here, it's going to be very difficult to integrate, okay? So what we're going to do, we're going to say this is the same as the integral of this x to the power 3. I'm going to write it as x squared, okay? And then multiplied by x. So x squared multiplied by x is the same as x power 3, right? And then I'm going to write it, the root of 4 minus x squared, and then dx, okay? So why am I doing this? Because in this question, okay, I can't solve it without the substitution method. So I want to make this equation to be very easy to work with when I introduce the substitution method. Okay, no wonder I'm creating this part here. You see that it will be canceling out somewhere. Okay, so it means now I can choose my dv and my u. Okay, once I do that now, I can choose my u and my dv. So my u, I'm just going to choose x squared. Okay, and then my dv, I'm going to choose this whole thing that has remained. So x, the root of 4 minus x squared, and then dx. So I think in tutorial sheet 2, there's some question where I'm differentiating something like this. Okay, so here it means my du will be equals to 2x dx. Okay, so that will be my du. And then here, it will be my v will be equals to the integral, okay, of this guy here. So what will be the integral of that guy there? Okay, so it will be the integral of x, the root of 4 minus x squared, and then dx. So this one here, we can only integrate it using trigonometric substitution or just the u substitution. Okay, but for you guys, I think trigonometric substitution, you don't do it. I doubt if you do. So we are going to use the u substitution. Okay, so I'm going to say let whatever is under the square root there, okay, let it be equals to 4 minus x squared. Okay, and then from there, I'm going to find my du. Okay, so I'm just working on this one here. I'm just working on this one. Okay, or maybe we can use another variable here to to avoid confusion. So I would say let my W be equals to 4 minus x squared. And then I find my dW be equals to, okay, so my dW will be equals to, here I'm just differentiating with respect to x. So the 4 is a constant, so it's 0. Then this one is becoming minus x, okay? And then I have dx here. So because I'm differentiating with respect to what? To x. Okay, so this implies that what? So we want to solve for dx here. So dx, I'm going to divide both sides by a minus 2x there. Okay, so it will be dx is equals to dw divided by minus 2x, like that. So you see that this guy, when I substitute it here, it's going to cancel out with this x. No wonder I'm using substitution there. So it means this guy will be equals to the integral. This x, I can keep it just there. Okay, and then here, where there's the root there, I'm going to say root of, but I said whatever is inside here was just w. So it is root of w. And then this dx has become now dw over minus 2x. Okay, so you see there that this x and that x is going to go. So what I'm remaining with is, okay, the integral of the root of w over minus 2 and then dw. So I can easily integrate that, right? Okay, so I know that the square root of a certain number is the same as that number or half. Okay, so this is the same as, so this minus 2, I can take it outside the integral. So it will be minus 1 over 2, okay? And then the integral of, this root of w is the same as the w to the power half. And then I have w. So now I can integrate that part, okay? So let's just look for some space here. Okay, so we're going to say, let's integrate this part, okay? So that part, when you integrate it, it becomes what? Okay, so when the meeting cuts, just join in using the same link. So this part now, when you integrate it, this part, okay, it will be equals to minus 1 over 2. Then the integral of this, we just add 1 to this and then divide by that same power, right? So it will be w half plus 1 divided by half plus 1. Okay, so this will just be equals to minus 1 over 2. And then w, so half plus 1, that is the same as 3 over 2, and then divided by 3 over 2 as well, like that. Okay, so what do we get? Okay, so we were working on this. So I said I had minus 1 over 2, and then w to the power 3 over 2 divided by 3 over 2. So dividing by 3 over 2, it's just the same as multiplying by, it's just the same as multiplying by 2 over 3. Okay, so this one becomes minus 1 over 2 multiplied by, okay, w to the power 2, to the power 3 over 2 multiplied by, so dividing by 3 over 2 is the same as multiplying by 2 over 3. Okay, so what do I get there? So I can erase this part. So what I get there is, okay, minus 1 multiplied by this 2, it will be minus 2 over, and then this 2 multiplied by this to just be what? 6. Okay, actually here I shouldn't even write it like that. I can just cancel out because this 2 and this 2 cancel out. So I remain with minus 1 over this 3. Okay, and then I have w to the power 3 over 2. Okay, so it means here, this one is the answer to this integral. So this is our v here. Okay, so we can now put back, what did we say the w was? The w was 4 minus x squared. So we can put it back there. So we're going to say this is the same as minus 1 over 3. And then where is w? We put back the 4 minus x squared. And then to the power 3 over what? 2. So this is my v here. Okay, so now I can use this formula here because I have my u, my du, my dv, and my v, which I found this one here. So I can put them now in the formula. Okay, so let's do that. We see where we're going to end up at. Okay, so, okay, can you erase this? Okay, so the integral of x to the power 3 root of 4 minus x squared dx is equals to, so our u, we had chosen it to be x squared. Our v is this one now. So minus 1 over 3, 4 minus x squared, the power 3 over 2, minus the integral of v, Okay, the v is the same thing. 4 minus x squared to the power 3 over 2 multiplied by du. So du, it's a 2x dx. Okay, so let's manipulate this now. So it means here we have it's equals to, this one here is minus x squared over 3. And then I have this guy now, 4 minus x squared over 3 to the power 2. And then here, I can factorize, I can move this negative to the front here. So this negative and this negative, I have a plus, okay? The integral of this 2x here, you've seen this 2x, and this 1 over 3, okay? They combine, they're going to form 2x over 3. Remember, this negative has gone outside, right? So I have a positive 1 there. So positive 1 multiplied by 2x, and then over 3. And then I have 4 minus x squared to the power 3 over 2, and then dx. Okay, so you see that here, again, we have to evaluate this integral. Okay, so we integrate this integral again, not by parts, but by what? Substitution. So let's simplify it more before we do that. So this will be minus x squared over 3, 4 minus x squared to the power 3 over 2. Here, I can say that 2 over 3 is a constant. So I can move it outside the integral. So it will be 2 over 3 outside. Then the integral of x, and then I have 4 minus x squared, and then 3 to the power 2 dx. So now, this one here, in this form, the way it is here, I can easily integrate it by using what? Substitution. Okay, so let's erase this part. Okay, so I'll say the integral of x to the power 3, the root of 4 minus x squared dx is equals to, here it will be minus x squared over 3, 4 minus x squared to the power 3 over 2, plus 2 over 3. And then now I have to evaluate this guy here. Okay, this guy here. So I evaluate this guy using substitution. Okay, so I'm going to say let my u, or let's just use w again, be equals to whatever is inside there. So it will be 4 minus x squared. Okay, and then my dw, okay, will be minus 2x dx. Okay, and then now I can put in this formula to see the integral that I'm going to come up with. Okay, so I'm going to say the integral of x, and then I have 4 minus x squared to the power 3 over 2 dx is equals to the integral of x, okay? And then where there's 4 minus x squared, now I put w to the power 3 over 2. And then where there's dx, okay, I forgot to make dx the subject here. So I make the dx the subject here. It's just be dx is equals to dw divided by minus 2x. Okay, so where there's dx here, we are putting this. So dw divided by minus 2x. So that's what we have. Okay, so from there, we're going to say what now? We're going to say this x and this x will cancel. So I just remain with a minus 2 down there. So I can factorize it to come out there. So it is minus half, this one. And then I have the integral of w to the power 3 over 2 dw. So how do we integrate this? Very simple, because just the power here. So we're going to say the power, we add 1 to this 3 over 2. Okay, so if I add 1 to 3 over 2, so this one is the same as 2 over 2. So this will be 5 over 2. So the new power here, when I integrate, okay, it is 5 over 2. And then I divide by this same power, 5 over 2. So now dividing by 5 over 2 is the same as multiplying by 2 over 5. Okay, so I'm going to erase this 5 over 2 and then just multiply this thing by 2 over what? 5. So what we have is this 2 multiplies, cancels out with this one, I mean. So I have minus 1 over 5, and then w to the power 5 over what? 2. So the integral that came after 2 over 3, the integral that was here, is now just this guy. Okay, so we're going to put in front of this 2 over 3, we're going to put this guy here. Okay, so let's just erase this part. Okay, so you've seen that the E1 was interesting, right? Because we had to do a lot of things. So the integral that was just after 2 over 3, it has become this. So that is minus 1 over 5. And then the W was just 4 minus x squared to the power 5 over 2. Okay, so it means our final answer will just be minus x squared over 3, 4 minus x squared to the power 3 over 2 plus. Okay, so there we can multiply this 2 over 3 and this minus 1 over minus 1 over what? Minus 1 over 5. Okay, so what do I get there? So I get minus 2 over 15. Okay, and then 4 minus x squared, and then 5 over 2, and then plus c. Okay, then it will mean that we are done with this question. So it's quite a long question. Okay, because we had to do those things that we did there. Okay, so I hope you followed it. If you didn't follow it, I'll still upload the video so you can watch it anytime. Okay, you can watch it anytime. Okay, so I think that's that on this one. Okay, unless someone has some questions that they want to ask. Okay, do we have any questions? No? Okay, so that will be our final answer, this one here. Okay, so now let's look at the last question. Okay, so the last question is a very simple one, unlike this one. But okay, unlike this. So the last one is very simple. So let's erase this. Okay, so the last one is the integral of sine x ln of the cos x dx. So let's pick our u, okay, our dv, and then find our du and our v. So in this case here, okay, I'm just going to pick my u to be the ln of cos x. Okay, because I know I can easily differentiate this one. And then my dv will be sine x dx. So here I can find my du, right? So how do you differentiate? So here we have two functions, okay? So it's like we are differentiating using the chain rule, okay? There is a function inside of a function, okay? Because this is ln, and then I have a cos x inside. So how do you differentiate this guy here? Okay, so since this is ln of this guy, we said when we are differentiating a ln x here, we first differentiate this, okay? So what is the derivative of this is 1, and then divided by itself. So it will be x like this. So even here, we're going to apply the same thing, okay? We're going to say, what's the derivative of cos x? The derivative of cos x, it's minus sine x, okay? Divided by itself, which is what? The cos x. So this is the cos x here. Okay, and then dx. So that would be our du. And then what would be our v? So v, I integrate this side, I get v. When I integrate sine x, what do I get? Okay, I get minus cos x. Okay, so I have whatever I need. So I can apply my by parts formula. So I'll say the integral of sine x ln of cos x dx is equals to, so what is my u? My u is this guy. So I'll write it here, ln cos x. What is my v? It is minus cos x, okay? And then minus the integral of u, which is minus cos x, and then multiplied by the du. The du is this guy, so it will be minus sine x over cos x, and then dx. So we see from okay, we see from here that this cos x and this guy is going to cancel, right? So I have this minus multiplied by this minus. Okay, so it means there I have this whole thing here is equals to, okay, minus cos x. I'm just writing the minus cos first, and then ln of cos x, okay, and then minus the integral. So this negative and this negative will go. So I'll just have the integral of sine x and then dx. So this will be minus cos x ln of cos x, okay, minus, what is the integral of sine x? Just minus cos x. Okay, and then we add our constant of integration, which is c. So from there, we see that we have our final answer. So our final answer will just be minus cos x ln of cos x, and then negative and negative give me plus cos x, and then plus c. So that will be our final answer there. Okay, so any questions there? Because that would be, I think that is our last question for today. Any questions there? Okay, so if there are no questions, okay, then we'll end there for today. Okay. But for those who'd like to access the full videos to all the other tutorial sheets, okay, you can register and then you'll be able to find them on our website. So when you register on our website, you see something like this. So if you subscribe for a course, you see enroll there. So you can open the course there. Okay. You go to the folder General Math. Okay. So if you want to learn some topic, you go in this folder here, lessons and tutorials. Okay, you open it, you're going to find lessons on different topics. So from the sets where you started from, you can see polynomials, all these topics here. Okay, we have some videos on them. And then if you want the tutorial sheets, okay, so this was a tutorial sheet for Unilus, right? You should go to the tutorial sheet section. So if you are from Unilus, you're going to find the folder for Unilus. So this is the Unilus folder there. Okay, you open it and then you go to, this is first semester or first. This is second semester. So you open second semester. Okay, and then you go to the video solutions here. So here you're going to find the solutions to all the tutorial sheet that you have so far. So there's tutorial sheet 1, 2, 3, and 4. So those questions that we are solving for is from tutorial sheet 2. So I'm just solving the last question and then I'll upload the full videos here. But for tutorial sheet 1, 3, 4, they're already there. Okay, the full videos. So you can watch those as you are preparing for your mid-semester exams. Okay, because what they do sometimes they just get the same questions from the tutorial sheet and then they bring it in the exam. So if you're able to solve the questions in all the tutorial sheets, then you are safe. Okay, and then you can also go to the past paper folder. Okay, you can find some past paper videos that we did there where we are revising these things. All right, so thank you so much for coming through. I end here for today.